All right, so we're going to be doing some addition of vectors, and I've got some graphing background to help us with that. It's a little bit of a process, and you have to understand what all the symbology means in order to do it appropriately. So I'm going to draw a little system. It does help to draw a system for each one of these. So this is going to be my first system right here. Okay. And it doesn't have to be perfect. It just has to have an origin, right? Okay, so the first thing, we note that this is a negative 20 degrees. We need to find that on the Cartesian coordinate system. And the negative just means to start measuring from measuring down, right, instead of up. We know on the y-axis, up is positive, right? This is positive. And on the y-axis, down is negative. So if you can remember that, this is the positive side of the y-axis, and this is the negative side of the y-axis. And this little sign right here is just telling us which direction, towards which axis, toward which side of the y-axis we go toward. That's all it means. So if it's a negative 20 degrees, then we start measuring. We go toward the y-axis on the bottom first and go this many degrees. That's all you have to remember to get this right. So if we go towards the negative side of the y-axis, 20 degrees, right? Then that's where our angle is located. But then we have a negative sign on this length for the hypotenuse. We know that you can't have a negative length. So what this just means is I want to go in the opposite direction this length from where this would be. So if we go down 20 degrees, I'm going to go this way. All right, let me orient that appropriately. Put this to the center through the origin. Sometimes it doesn't pop in the right spot that I want it to. So what we did was we went down 20 degrees. So this is 20 degrees. Once you get there, this just tells you how far, in which direction to go. And this tells you the degree of the angle. So this just says goes toward the negative side, 20 degrees. It's still a 20 degree angle. It is not a negative 20 degree angle. Okay? That's just where it lives. You drop the negative for the sake of calculations. That's all it is. It's a direction. It is not a value. Okay? You kind of think of it like that and you'll get your head wrapped around it. Now, if this is negative 5, this is telling me I need to go to the other side. So then this would be 20 degrees and this would be a positive 5 because think of this as the center of this is the origin. Think of this as the center of the number line. Okay? On a regular number line, if I wanted the opposite of 1, 2, 3, 4, 5, right? If I wanted the opposite, I would go in the opposite direction. 1, 2, 3, 4, 5. I would flip it. Don't let positive side and negative side of the x-axis change that thought process for you. If it's negative 5 here, we want a positive length because a length cannot be negative. It can't. So because it can't be a negative length, that tells me it's going in the opposite direction. So then once you get here and all your values, this 20 degrees, it's still 20 degrees. It's still 20 degrees. An angle is not negative. It just tells you the direction that it's going, right? So once we get there, we can erase all of this because this is no longer relevant. It is not even a part of the equation. All that was telling us was direction. When it comes to Cartesian coordinate systems, we don't have a negative degree or a negative length, right? We do have negative values, but it's only in relation to where it's located on the number line, the X number line or the Y or the x-axis or the y-axis. Okay, it's only relative to position. There's no negative length and there's no negative degree in regards to the calculations themselves. So this becomes our right triangle. This is where it lives. And this is going to tell us whether the x or the y is positive or negative. In this case, we have a negative r because it's going to the negative side of the x-axis, and a positive u because it's going up to the positive side of the y-axis. Okay? All right, I know that might be a little bit confusing, but just know this is telling us its location, all right, not its actual value. We get its actual value from the number line themselves. Okay, now that we actually have that, we can write our sine and cosine. Remember cosine? We got the hypotenuse times the cosine. That's going to be the r, because cosine is for the x-axis. So it's 20 degrees is equal to, this is a negative r. And then we have 5 times the sine, that's going to be the y-axis value. 20 degrees is equal to a positive u. The only reason we put that negative sign on there is so we can transfer it to the value so we get the location on the negative side of the y-axis, or I mean the x-axis. Okay? That's just a location, it is not a value. So we just do this on the calculator now. If I can get it to pull up, there we go. Get the scientific. So then all we do is this. We say 20 cosine times 5. Round it to 2 places, be 4.70. I know, it's 4.70. You feel like you want to drop the 0. Don't, just leave it. 4.70 is equal to negative r. We hand off the negative because we never want a variable to be negative. So it's negative 4.7 r, 4.70. Okay, now we do this one. Same thing. 20 sine times 5. 1.71. That one at least was easy for us. 1.71 is the value or the length of u. So that would be plus 1.71 u. Now we do the other one. So I'm going to switch to blue for that one. I am going to do it on the same system, I think. Just because I know these are going to be... No, they're really not going to be. Sorry. They're going to be in the same quadrant. If they're in the same quadrant, then you definitely want to do a separate system, because it can be really confusing otherwise. So I know they're going to be in the same quadrant, so I'm going to do a different system. I am going to do it in blue. So 115 degrees positive. So this is 90. This is 180. So it's somewhere between 90 and 180, right? It's going to live over here. I just need to figure out where. I need to take 90 from this, so that's going to be at the 25. Say right about there somewhere. If this is 25 degrees, I need to figure out what this is. And this is going to be 65 degrees right there. So you see it lives similar. The length here is 4. This is still a negative r, and this is still a positive u, because it lives in the same quadrant, right? And that quadrant is negative, positive when it comes to x and y values. So negative x, positive y. We do the same exact thing. We take the hypotenuse. Actually, let me move this lower to give us some more room. We take the hypotenuse times the cosine of the angle. That's our negative r. Hypotenuse times the sine of the angle. That's our positive u. Now we just do the calculation. So 65 cosine times 4. 1.69. That one's easy. The negative reminds me to flop it. Negative 1.69r. And then I've got this one, 65 sine times 4, 3.63. So that would be plus 3.63u. Okay, so now all I have to do is stack these together. Negative 1.69r plus 3.63u. Draw my line. Bring down my u. 4. 13, carry 1, that's 5. Put in my decimal. R, that's a positive sign. So 9, 13, carry 1, that's 6, that's a negative. Negative 6.39r, and the reason I add them together, they're both the same sign. That's our solution. This right here is our solution. Negative 6.39r plus 5.34u. Next problem. Okay, we've got another negative negative, so we just wrap our heads around that to start with. And we go ahead and draw our Cartesian coordinate system. Okay, so we've got a negative 15, so I'm going to go this way. Let's do this one in red. All right, so negative 15, and it needs to be too long, but it's going to go the opposite direction. So this is going to be 15 degrees to positive. There we go. All right, not hard. Negative r, positive u. This one is 110. It's going to live in the same quadrant, so I'm going to draw a new system. I'm going to do this one right here. I know it's a little wonky. It's okay. This one's blue. So 110 would be 20 this way. So that would be 110. Right? So it would be 20 over 90. But I have to measure it relative to the x-axis, so that would be 70 degrees right here. Negative r, positive u. So in red, 2 times cosine of 15 degrees is negative r. And this is 5. 5 times cosine of 70 degrees is negative r. So when I find that, so 15 cosine times 2, 1.93. Okay. 70. Oh, I messed that up, didn't I? No, I didn't. It's a different problem. Times 5, 1.71. Okay, so now we'll do the sine. We'll do the u. So 2 times sine 15 degrees is u. 5 times sine 70 degrees is u. Clear that. 15 sine times 2. 0.52 is u. And clear that. 70 sine times 5. 4.70 is u. Okay. So now we just put them together. I've got negative 1.93R plus 0.52U. And I've got negative 1.71R plus 4.70U. All right, so that's U, 2, carry 1, that's 5, that's positive. Bring down the R, that's 4, that's a 6, carry 1, so it's a negative 3.64 R plus 5.22U. That's your answer. Okay, these are not hard. The hard part, the math is not hard. I mean, you see, it's just a little thing on the calculator. The hard part is understanding what this means and what this means in order to find the proper location in the system, right? That's what opposite direction. That's all that means. Go the opposite direction from what you normally do, and then draw the line in the opposite direction. That's it. If you can remember that, you can get these right every time. Because this part is just a few buttons on the calculator. You just have to remember how your calculator works. Mine works such that you type in the degree and you hit cosine and then you multiply by 2. So you work backwards. Yours might be different. Yours might mean that you have to hit the cosine button and then the degree and then multiply by 2. It's up to you, or up to your calculator, I should say. Make sure you know how your calculator works. If you don't have the direction manual, you can always Google for the directions for your type of calculator. How do I find the cosine on a whatever type of calculator? And it should pull it up, and you should be able to do it. Like I have my manual calculator. I'm going to show you on Google how to do this. Okay, I've got my keyboard. So I'm just going to go right here. You can see the last thing I looked up. I love lemony chicken. How to find sine on a TI. Let's say this is my calculator. I have a TI-30X. Okay. It's going to give me a video to show me how to find it. So that's awesome, right? So you just watch the video. It actually tells you the section to watch and plays it for you. So if you do that, like if this is the one you have.
The sine function, abbreviated SIN, is a unary function. You enter the value of the angle, x, and press the sine button to get the result. Angles can be measured in degrees or radians.
So
the calculator can accept either.
Easy peasy, right?
First turned on. The letters D.
And let's see, let's go back. It actually tells you first enter the angle, then press the sine button. Essentially, you input the angle before the function key, so you find the sine. So this is on this particular calculator, right? And then this guy even shows you pressing the buttons. Let's watch this guy. Okay, we don't care about this one. Skip.
In this video, we're going to take a quick look at how to work the trig functions on your TI-30XA. Again, with this calculator,
And by the way, this calculator is worth about $10 or $12 at Walmart, depending on where inflation is at the time, right? A couple years ago, you could get these for less than $10. Now they're maybe a little over, but this is ACT approved, and it's a really good, solid calculator. You don't need a fancy graphing calculator at all. You don't have to buy one. When you get to graphing, you just download the Desmos app for free on your smartphone. So all you need to do is spend $10 or $12 on this particular calculator. This is the one Miss Anna prefers. This is how, she knows how to tell you the buttons. This is the one I have. It's very useful. Just the Texas Instruments 30XA. It's a great little calculator.
Somewhat clumsy and unintuitive. The key to the trig functions is you put in the angle first. So if you want sine 30, you type in 30 sine and not sine 30. So everything is backwards. So if you know your basic trig, you should know the sine of 30 degrees is a half. So 30, and then you press sine, and you get 1/2. You've got above the sine functions, you've got your inverse sine. So for example, if we have 0.5, type in 0.5 and then press second function and then the sine button. So the second function activates the yellow text. So inverse sine, and this should come to 30 as it does.
All right, so I hope that helped you guys. It's not hard. You just got to know how your buttons on your calculator work to get where you need to go. He did both the starting with the sine, finding the sine, and then using the sine inverse to find the degree. So you guys have got to be able to, be a self-starter, right? Pursue your own education. Ask questions. If you don't understand, if I'm not saying it in words that you can understand what I'm talking about, ask somebody else. Ask Miss Anna. Google it. Go to khanacademy.com. Find the resources that you need so that you can be successful. It's up to you to pursue as much as you need to pursue. And this is a great place to start asking your teacher. That's always where you should start. Ask the person who taught it to you. Can you explain that better? I'm not getting it. And then, sometimes parents remember algebra. Sometimes they don't. Ask them anyway. They'll be, appreciative that you still depend on them for some answers in life. So give them that. It's okay. But then they don't have it and they're like, look, I don't do math. You're going to have to ask somebody else. Use your resources. You've got the internet. Oh my goodness. We did not have the internet as a kid. You guys don't know how blessed you are to be able to have a variety of resources at your fingertips like that. If it wasn't in the textbook, if we didn't understand the textbook, we had to wait. If we had a friend who was smart, we could call that friend who was smart on the phone and talk about it. But we didn't have any computers. We didn't have any smartphones where we could text each other pictures of the problem. We had to explain which problem it was in the textbook and get them to walk us through it on the phone or come over to our house and help us. That was it. That's all we had. So you guys have tons of resources. You really don't have any excuse for figuring this out. And I'm not saying that to be mean. I'm not saying that to, belittle at all. What I'm saying is you guys are blessed. You have all these resources. Use them. All right, I'm going to quit preaching. Let's go to the next problem. Okay, so this one says that we've got, and I just got the picture, but it says 2 ropes are attached to a point and pulled on with the direction and magnitude shown. So what that means is someone's on the side pulling and someone's on this side. They're pulling, and this is the point that they're pulling from. So that means you've got some force going on here in this direction. You've got this and you've got this. Those are your arrows. They're going away from the center because the 2 ropes are being pulled on, right? So that's going to affect how you do the problem. So first of all, let's look at this angle here. We've got 58 degrees from here to here. This is your angle, your 58-degree angle, with a magnitude of 40. That's your hypotenuse, right? So this creates a right triangle just like that. So this is your hypotenuse of 40. So if this is your, this is going that way, and this is going up, so it's positive, so it's a positive U, and this is going to the left, so it is a negative, it's away from, so it's going to be a I think it's a negative. Yeah, that's going to be a negative value. Is it going to be a negative value? Yes, that's going to be a negative r, because this is the origin, basically. And this is your Cartesian coordinate system. Think of it like that. So this is going to go up, and this is going to go to the left. So it's a negative r value. This is a positive u value. So you're just going to set this up the way you would normally set this up, right? As far as sine and cosine is concerned. Here's your hypotenuse is 40. And then you've got your cosine of the degree of measure. And that's going to be equal to your negative u. I'm sorry, negative r, because I am not paying attention. And then you've got your u here, which is going to be 40 times your sine of 58 degrees, which is going to be your positive u. All right, so when we do those calculations there, we're going to get 58 cosine times 40. Round it to two places, it's going to be 21.20 is equal to negative r. And then when we do the u, we get 58 sine times 40 is going to be 33.92. The positive u. Okay, so we can go ahead and write these over here. Negative 21.20 r plus 33.92 u. Okay? All right. I'm going to cover that up for just a second so we can look at the one over here. We're going to do this in blue. So this is going out. Let me get blue, sorry. So you've got to think about its direction from the origin. This is the origin. It's going to the right, so it's going to be a positive r. And it's going up, so that's going to be a positive y, right? So that's a positive u because it's going up. So we have the magnitude 30, the hypotenuse of our right triangle, times the cosine of 22 degrees is going to equal a positive r. And 30 times the sine of 22 degrees is going to be a positive u. So now we just have to do those calculations. 22 cosine times 30 is 27.82. And then we do the 22 sine times 30 is 11.24 is our u. Okay, so now we just have to rewrite that, and that's going to be positive 27.82 r, positive 11.24 u. We add all of those together, and we are going to end up with 45.16 positive u, and then 21.20 minus 27.82, or I should say negative 21.20 and a positive 27.82. That's going to give us a positive 6.62 to the right. So that is our resultant force. It's exactly the same thing that we've done before, except now we're applying a direction that is going to affect our positive or negativeness, right? So if the arrow, that's all you need to remember, if the arrow on the X or Y axis, right, is moving in that direction, in not that direction, in the direction on the axis that makes it negative. So if the arrow is moving to the left, it's going to be on the x-axis, it's negative. If the arrow is moving, or the force is moving to the left, it's negative. If the force is moving to the right on the x-axis, it's positive, just like the x-axis itself. If the force is moving up, right? If it's up, that's your y-axis. That means it's positive. If the force is going down, that's still your y-axis, and it's negative, just like the Cartesian coordinate system. It does not matter whether it's pulling from the origin or not. What matters is where's the origin of pull. Okay, so if you have a problem like this, and it is saying that it's going this way and this way, then you've got a negative R and a positive U. Even though it's pulling from over here, it's moving to the left. Okay, and likewise, if you have a point, it's anchored over here and it's pulling this way, then it's a positive R. It's going towards the positive side of the x-axis. And if it's moving this way, even though it's on the positive side of the x-axis or the y-axis, if it's pulling downward, it's going to be negative. Okay? That's what you got to remember. If you have a point here and it is pulling this way and this way, then this is a positive R, this is a negative U. Even if it stops here, it's the force is dragging it down. Dragging something down is negative. Okay? Pushing something up is positive. Lifting up people is positive. Dragging them down is negative. Okay? You can kind of relate that on the y-axis. It's harder to do that on the x-axis, but you could say that forward progress in life is positive and backward progress is negative. If you think of moving to the right as forward, and you got to figure out a way to think about it that makes you remember it. You could also just relate it to the positive and negative signs on the Cartesian coordinate system, and in the direction of pull or push, the direction that the force is moving is going to be the sign of that leg of your right triangle. Whichever direction it's moving in, if it's moving towards the negative side of the Cartesian system, it's negative. Doesn't matter where it's located. It's the direction of force that matters. Basic physics. All right, let's move on to the next problem. Okay, my bad. That still is the next problem. We didn't finish this one. Okay, so I'm going to convert these to polar form. That was the next part. That's what we were supposed to do next. So converting this to polar coordinates. Let me get my blue pen here. So we have to first of all find the degree of measure. We're going to take y over x. So 45 over 6.62. That, by the way, is the tan of theta. Y over x, or the u over r is equal to y over x. That's how you find tan of theta. And you're going to have to use your inverse function to do that. So let's pull up our calculator. And we're going to say 45.16 divided by 6.62. That's our value. We leave it in the calculator. We don't round it. Okay, leave it just like that. And then hit your second function and your inverse tan. 81.66. It's a 0 next, so that's it. It doesn't round. That's its value. This is your degree of measure. So theta is equal to 81.66 degrees. That's your angle. So that would go in here. 81.66 degrees. And now we're just going to use Pythagoras' theorem to find the length of that angle, or the length of the vector. So all we have to do is put it in here. And this is another form of Pythagoras' theorem. It's just doing it all in a singular step. So we take the x value, square it. We take the y value, square it. These are just your legs squared, right? And then this would have been your hypotenuse squared, right? So we just went ahead and took that unsquaring of the hypotenuse and put it over the top of these two squared, just like normal. Not a big deal. So when you do that, you're going to get, that's your force. F stands for force. You get 6.62 squared. I'm going to add that to my memory. This is a trick you can do. Memory plus, clear this, 45.16 squared. Memory plus, okay, clear that out. Memory recall. All right, let me clear my memory and double check my math. 6.62 squared. Memory plus. Let me hit my memory recall. Okay, it's in there. So now I'm going to let me clear that. 45.16 squared. Memory plus. Memory. Okay, so I did it right the first time. So now that is this in here. Now I'm going to find the square root of that. 45.64. That is what goes here. 45.64. F is 45.64 in length. That is your hypotenuse. That would be your value there. Okay? So use the memory plus option to hold these two so you don't have to write every little step down. Makes it a little bit easier. Then you hit memory recall, pulls it back up, and then you hit that square root button and it finds it for you. Makes life a little bit faster. And that would be your resultant force in polar form. Okay. Like I said, long drawn out process. This form of Pythagoras' theorem makes it a little bit faster. Now we can do the next problem. Okay. All right, so here's our next one. Again, we are pulling on both ends of the rope according to the directions of the problem. So this is pulling straight up. Straight up. So what does that mean? Sorry, I had a plane going overhead, so I paused it. It was kind of loud. And I live right in the pathway of the airport. Okay, so it's going straight up. So it's got a height of 8 or a length of 8, but it has no slope. It is a vertical, it's a vertical line, right? So we don't even have to do any math to write the rectangular coordinates for this side. None at all. We know that it isn't moving at all on the x-axis because it's going straight up. So that means we've got a 0.00 r. And we know it's going up 8 spaces on the y-axis, so 8.00 u. No math necessary. That is its location. When there is no slope, it's a vertical, then it is 0, on the x-axis. If it were to move flat across the x-axis, it would be 0 on the y-axis because it wouldn't be moving at an angle. So that's what a vertical line means. A vertical line means less math. A horizontal line, less math, right? You just put the 0 where there is no movement, where there is no change. Okay? This is always going to be at the origin, so therefore it's at the 0, 0 at the origin of the Cartesian coordinate system. This one we have to do a little math for. Not a lot of math, pretty straightforward. Again, this is our right triangle. It's moving this way, so it's moving both up and to the right. So up, positive U, and to the right means it's a positive R. So we have got the length of the hypotenuse times the cosine of 27 degrees is going to give us our R value, and the hypotenuse times the sine of 27 degrees is going to give us our U value. We do that really quick on the calculator because we're geniuses. We can do that really quick. 27 cosine times 10, 8.91 R. And then we do 27 sine times 10, 4.54. Okay? Positive. So we're adding together 8.91 R plus 4.54 U, 4, 5, 12, 8.91 R. There we have our rectangular coordinates. Now we can turn those into polar coordinates. Really, really, really easy. We'll find our degree of measure by again doing the U over R, right? The tan of theta is going to be U over R. U is the Y, it's Y over X. Think of it like that. That's what it's always going to be. So our tan of theta is equal to 12.54 over 8.91. We do the math on that really quickly. Hang on. 12.54 divided by 8.91 equals this number, and our inverse tan, 54.6, and we round that to two places, 1. So theta is equal to 54.61 degrees. So that would go here, 54.61 degrees. Now we got to find our hypotenuse. So that is going to be our force is equal to the square root of 12.54 squared plus 8.91 squared. It doesn't matter. You're going to put both of these sides in here. It doesn't matter which one is X and which one is Y because you're adding them together. Commutative property, it doesn't matter, right? Right. So now we just do that. We say, let's full memory recall. Okay, it's clear. 12.54 squared, memory plus, clear. 8.91 squared, memory plus, clear. Memory recall. The square root of that number is 15.38. So F is equal to 15.38. That is the length of our hypotenuse. Rectangular coordinates helps you find the polar coordinates and vice versa. So remember, you see, just looking at this, right? The amount of actual stuff you're writing down. Not a lot. This you didn't even really have to write down. This was just to remind us of the steps. If you have that written somewhere in your notebook as on a reference page or the front cover, wherever it's handy, then you don't have to write that down on your paper. You can just go straight to this, right? Which is the point. There you go. This is always going to be to find the hypotenuse or the force, square root of your U value squared plus your R value squared, or vice versa. R squared, U squared, doesn't matter because you're adding them together. You're squaring them individually and adding them together. So there's not some weird thing going on. So it doesn't matter what order these are in. If you remember it as FUR, F-U-R, and you can just picture that, you'll get it right every time. Right? Ultimately, what's going on here, you have F squared is equal to U squared plus R squared, but we're unsquaring everything, and this cancels. So you have F is equal to the square root of U squared plus R squared. That's how we get to this step right here. It's skipping this bit to just find the value of the hypotenuse. I've probably explained that in a video before. I just, I'm an over-explainer. I run my mouth. We're already into this 45 minutes. Let's keep going. All right, this one was tricky. Why is it tricky? Because of the arrowheads. You've got to look at the direction that they're going. They're going in this direction. So when we draw our other side relative to the x-axis here, we have to think about the direction of the arrow. It's not about where the origin is on the Cartesian coordinate system. It's about where the base, or it's about where it's pulling it from. And it's pulling it from here, right? It's going down and to the right. So this is moving down, so that's a negative U. And it's to the right because that's where the arrow is pulling it towards. So this is a positive R. This is going up, right? And to the right, up and to the right. This is its starting point. You always got to look at its starting point. It's going up to the right. So this is going up, so it's a positive U. And it's going to the right, so it's also a positive R. I know that can be confusing. Actually, let me use the same color. That'll help a little bit. So this started here, and it's going this way. So to the right is going to be a positive number. But it's going down and to the right, so that's a negative number. All right, and then this one, let me change the color to this. We've got this right here. It's starting here and going that way. So it's going up, so that's a positive U, and it's going to the right, so that's a positive R. Does that make sense? Because of that, that's going to change the way you do the problem, the values here. You've got to write it based on the values here. So we've got a 40 degree here. We still do it relative to the x-axis. So we're still going to say 2 cosine 40 is equal to a positive R, because this is a positive R. And then 2 sine 40 is equal to negative U. That's for this one. For this one, we would say 1 cosine 45 is a positive R. Move that over just a little bit. And 1 cosine, I already did cosine. This is sine. Sine 45 is a positive U. So the direction of your force is what matters. Don't let the fact that they're both pulling towards the origin of the Cartesian system throw you off. It is about the force applied and the direction it's being applied in, not where it ends up. That's a little bit different than what we've been doing before. So you have to know the direction that it's being pulled or pushed. And that's what these arrows are telling us. So now when we do these calculations, we've got 40 cosine times 2, 1.53 r, and we've got 40 sine times 2, negative 1.29 u, because that's a negative u. Make that more u-like. Here we've got 45 cosine times 1 would be itself, so 0.71 r, and 45 sine, guess what, same number, and it's positive, so 0.71 u. Okay, 0.71 r plus 0.71 u, 1.53 r minus 1.29 u. Make sure I'm doing this right. I think I am. So then we would get 1.53 plus 0.71. Ooh, I can't do math. Look at that. 1.53 plus 0.71, 2.24 r. And then we have 1.29 negative and a positive 0.71, negative 0.58 u. That's what I get. All right, so that's correct rectangular coordinates. Now polar coordinates, same, we just take these and do the polars. Tan of theta equals y over x, so 0.58, we don't care about the negative sign, over 2.24. So that's going to be 0.58 divided by 2.24. Inverse tan is 14.52. I think that's right. Oh, no, that's not right. I'm sorry. I am so sorry. We do care about the negative sign. What am I thinking? Losing my ever-loving mind. Okay, it does matter. The negative sign does matter. Here's why. 0.58 negative divided by 2.24. Second inverse tan, negative 4.52. So it really doesn't matter to solving this. The negative sign matters to its location on the Cartesian coordinate system. So yeah, you could not put the negative sign on there, get the same result, but you want to give this in a different degree. So technically you could say negative 14.52 degrees, but you want to find that positive value. So you're going to say 360 minus 14.52. That's going to be your positive value, 345.48 degrees. Okay, we don't want to do this. This is how we find it, but we want to subtract it from 360 because this is down. Remember, it's on the system. We're measuring negative 14.52, which would be here, which is a positive 345.48. So the negative matters, but only in reference to its location, not the degree of measure. Does that make sense? Okay, this is the answer we want. We want the positive. Now, all we have to do is find the force, which is going to be equal to the square root of, and this doesn't matter if it's negative because the negative times the negative is a positive. So you can just put this. You can drop the negative if you want to. If that confuses you, then don't. Right? So now we just do that. 0.58. Actually, let me make sure my memory is clear. It is. Okay. 0.58 squared, add it to my memory, clear that. 2.24 squared, add it to my memory, clear that. Memory recall, find the square root of that. So F is equal to 2.31. That goes here. 2.31 at 35.48 degrees. I believe that's right. And it is correct. I double checked in the system. So it's all about where's the arrow, where's the force coming from. That is going to dictate your positive or your positive and your negative, your positive and your positive. If this were moving this way, then it would be negative and negative. All right, you got to think about where it starts from and where it ends up. That's going to give you your values, because force is not necessarily all from the same place. It could be going to the same place, like this picture, but coming from somewhere else, which changes its dynamic. Push is the opposite of pull, and we need to make that distinction. And that's what knowing where the origin is, that makes the distinction between positive or negative, push or pull. Okay? All right. That's the last problem in that lesson. If I didn't thoroughly confuse you, that's awesome. If I did thoroughly confuse you, stay for tutoring on Thursday or come to study group. That's all I got for now. I will see you guys on Thursday.